Good morning, students. Myself, Vijay Shankar from Electronics and Communication Engineering Department, Chipro Engineering College. Today, we are going to discuss about the examples in Fourier series. We already discussed about the 2 or 3 examples in the Fourier series. Let us see the remaining examples. So, obtain a polar Fourier series of the given signal. We already completed this. Find the trigonometric Fourier series for a periodic signal. Find the trigonometric Fourier series for a periodic signal. See, with the period of 0 to 0.5, the given signal is an exponential signal decaying. So x of t is equal to e power minus t and t is equal to 0.5 because the time period is the 0 to 0.5. To find out the trigonometric Fourier series, you have to calculate the a of 0, a of k and b of k. The equation, the Fourier series equation x of t is equal to a of 0, sum of k equal to 1 to infinite, a of k cos k omega naught t and sum of k equal to 1 to infinite, b of k sin k omega naught t. We already seen this one, how to find the a naught, a k and the b suffix k. By taking off a naught is equal to 1 by t, the integral 0 to t, x of t dt. X of t is a given, the signal exponentially decaying signal with a period of 0 to 0.5. So 1 by 0.5, 0 to 0.5 e power minus t dt. Apply the integral for the e power minus t dt and substitute the limitations, upper limit 0.5 and the lower limit 0, we'll get 0.7869 as a value of A0. As a value of A0. Similarly, to find the A suffix k, the formula for the A suffix k is 2 by t integral 0 to t x of t cos k omega naught t dt. So omega naught is 2 pi f. F is inversely proportional to the time period, 2 pi by t. And you can use this formula, e power ax cos bx is e power ax by a square plus b square, a into cos bx plus b into sin bx. So to substitute the a value and the b value in this equation, before that, what is the a value? Here, e power minus t, a is minus 1. As of x here, the t is there. And b value is 2 pi k by t. The t is nothing but 0.5. 0.5, you can get it in the numerator. 4 pi k is a b value. Substitute the a and the b values in this trigonometric expression and apply the integral with the limitations of 0 to 0.5. Apply the integration and limitations of 0.5 and the 0 to get the a of k here. A of k. So 4 into is a 4 because of 2 by 0.5 is a 4. E power a is a minus, and instead of x here the t is a variable, e power minus t whole divided by a square plus b square. A square is a minus 1 whole square, b is a 4 pi k whole square. And a is a minus 1 cos bx 4 pi k into t, b is 4 pi k and sine 4 pi k into t because its x value is a t. and the limitations is 0.5 and the 0. We already seen this one. And briefly, I am explaining. And simplify by substituting upper limit is a 0.5 to get these two equations, and a lower limit 0 to get these two equations. See, the cos 0 we know already 1, and sin 0 is a 0. Here the 0 will get a 0. And for first and the two second terms, cos 4 pi k into 0.5. 0.5 is nothing but 1 by 2, and 2 is with a 4, the cos 2 pi k, and here the sin 2 pi k. Sin 2 pi is a 0, cos 2 pi is always a 1. Cos 2 pi is always 1, and e power minus 0.5 is nothing but 0.606. After simplifying this expression, we'll get as minus 0.606 plus 0 plus 1 plus 0, 1.576 whole divided by 1 plus 4 pi k whole square. Means a suffix k is equal to 1.576 whole divided by 1 plus 4 pi k whole square. And similarly, to find the b of k is equal to 2 by t integral 0 to t x of t sine k omega naught t. And what is the formula for the trigonometric expression e power ax sine bx is e power ax by a square plus b square, a sine bx minus b cos bx. Here also the a is minus 1 and b is a 4 pi k. Substitute here 4 into, because 2 by t is a 2 by 0.5 as a 4, e power minus 1. E power minus 1 actually is a minus 1 is a and a t. E power minus t, 1 plus 4 pi k whole square into minus 1 is a value, a into sine bt minus b cos bt. Upper limit is a 0.5 and the lower limit is a 0 here. And similarly, simplify this expression to get 6.32 pi k by 1 plus 4 pi k whole square. How? First I will explain here e power minus t. Minus t means upper limit is a minus 0.5. Okay, the division is there. The 1 plus 4 pi k square, you can keep it as a multiplication factor. Whole multiply with the minus here, the minus sine 4 pi k, t is a 0.5 because I am substituting upper limit 0.5 minus 4 pi k cos 4 pi k into 0.5 is upper limit the substituting. So 0.5 means 1 by 2. 1 by 2. You'll get here the 4. 4 by 2 is a 2. Sine 2 pi. The sine 2 pi, the value is a 0. Okay. What is the cos 2 pi here? Cos 2 pi. Here also the 4 pi k into 0.5. 1 by 2. 2 pi. Cos 2 pi is a 1. So minus 4 pi k. Minus 4 pi k. So after substituting the upper limit of 0.5 in this equation, we'll get e power minus 0.5 minus 4 pi k. Okay. You see here. Upper limit minus e power 0.5 minus 0.5 into 4 pi k. This is the first term. And second term, you can see the e power minus t is a 0 here. 0 as of minus is there because the second lower limit you can substitute as a minus value. Minus sine 4 pi k into 0 because the lower limit is a 0. Minus 4 pi k cos 4 pi k into 0. So after substituting the lower limit, you get this equation. Now I can simplify this. What is a sine 0? Sine 0 is a 0. Cos 0 is a 1. Again, cos 0 is a 1. This value is a 1 here. Cos 0 is a 1. Now the remaining function is a 4 pi k only. 4 pi k. The second term is minus into minus. This is a minus here and here the minus. Minus into minus plus e power minus 0 into 4 pi k. 4 pi k. Now what is the common of these two terms? 4 pi k is a common term. Now I can find out minus e power minus 0.5 plus e power 0. Anything power 0 is a 1. That is equal to 4 pi k into what is the e power minus 0.5? Nothing but is a minus 0.606, my dear students. You can use your calculator and find out the value of e power minus 0.5. Definitely that is a value of 0.606 only, plus 1. And 4 pi k, you can find out the value of 1 minus 606. 1 minus 606 and you can multiply with the 4 here, see. So for this function, the 4 is multiplication factor. So whatever here, the 4 into minus 0.606 plus 1, the same 1.576 only. 1.576. After multiplying with the 4 also, my dear students. Here the 4 is there. 4 for these two terms, there is a 4 is multiplied. 4 into these two functions. So 4 into minus 6.606 plus 1 as a 1.56. 1.56 into 4 pi k. So what is a 1.56 into 4? Nothing but 6.32 into pi k. This is a b of k, my dear students. So b of b suffix k or b of k. B suffix k or b of k. Now we got the a of 0 is 0.70. A of 0 is equal to 0.7869 and a of k is equal to 1.576 whole divided by 1 plus 4 pi k whole square and b of k is equal to 6.32 pi k whole divided by 1 plus 4 pi k square. All these terms can substitute to obtain the Fourier series. To obtain the Fourier series here, x of t is equal to x of t. The first one is a of 0 or a suffix 0. And here the second term, sum of k equal to 1 to infinite. A of k into cos k omega naught t. A of k, 1.576 whole divided by 1 plus 4 pi k square, my dear students. And third term is sum of k equal to 1 to infinite. B of k into sin k. It's not the B of k into sin k omega naught t. What is the B of k? We got 6.32 pi k by 1 plus 4 pi k whole square. All these three terms after substituting of a naught, a k, b k, a suffix k and the b suffix k, we'll call it as a trigonometric Fourier series for the given periodic signal exponentially decaying with a period of 0 to 0.5. Understood, my dear students? You can practice. Using these equations a naught, a suffix k and the b suffix k values, we can find out the polar Fourier series with the same periodic signal with a period of 0 to 0.5. You can obtain the polar Fourier series here. Obtain the polar Fourier series of the signal. What is the polar Fourier series? X of t is equal to t of 0 plus sum of k equal to 1 to infinite d of k, nothing but with the square root of a suffix k whole square plus b suffix k whole square cos k omega naught t minus pi of k. I will show that. See, what is the equation here? X of t is equal to, in the polar Fourier series, d of 0 plus sum of k equal to 1 to infinite d of k cos k omega naught t minus pi of k. Where d of 0 is a of 0 and d of k is a magnitude of a of k and the b of k, and pi of k is a phase angle. Following, my students. So d of 0 is equal to a of 0 only, a of 0 or a of a suffix 0, and d of k is equal to, it's a magnitude of a suffix k square plus b suffix k square. And what is the pi of k here? The pi of k is equal to, pi of k is equal to minus tan inverse of b suffix k whole divided by the a of suffix k. Using these equations, find the d of 0, d of k and pi of k with the values of a naught, a suffix k and the b suffix k, my dear students. In the previous example, you see what the value of a of 0. A of 0 we got 0.7869. You see here, my dear students, 0.7869, and a of k is equal to 1.576 by whole divided by this equation, and b of k is a 6.32 pi k whole divided by this equation. Now, see the a of 0 or the d of 0 it is. Here I wrote this is C naught, Cn and the pi of n. C0 is equal to A0, but A0 is a 0.7869. And d of k is equal to, what is the a of suffix k? 1.576 whole square whole divided by 1 plus 4 pi k is a whole square, my dear students. Actually, some little bit mistakes are there here. 4 pi k square and a whole square also, plus b suffix k square is a 6.32 pi, it is also whole square here. 6.32 pi k whole square whole divided by 1 plus 4 pi k square whole square. In this, you can take both the denominator is the same. What is the denominator here? 1 plus 4 pi k whole square and whole square under root. These two are get cancelled. And here also the under root of 1 plus 0.76. whole square plus 6.32 pi k whole square. What is a 6.32? It is nothing but 4 into 1.56 only, my dear students. So you can use the calculator and see that 4 into 1.576 is equal to nothing but 6.32 only. Okay, so I take the common here, 1.576 whole square. In this, the value is of 1 plus 4 into 1.576. It is inside, that is also whole square. So 1 plus 4 pi k whole square is there. Here also some mistake. You can use this parenthesis. And in the denominator also 1 plus 4 pi k square whole square. And to get this function, d of 0 is, not the d of 0, d of k. So 1.576 under root and the 2 it get cancelled here. And here in the denominator 1 plus 4 pi k whole square and whole square. Here the one term is there and get cancel of the denominator square. So 1.576 and here it is a under root. It is also one mistake, my dear students, so verify this. Here you can keep one bracket and here also the bracket is there. And here also one parenthesis. And in this answer 1.576 under root of 1 plus 4 pi k whole square. Something went wrong here. This is a d of k. This total term is d of k. And this term is a d of 0. Nothing but a of 0. So d of 0 we got and d of k we got into cos k omega naught minus tan inverse 4 pi k. How we got this tan inverse 4 pi k? See, the pi of n is equal to pi of n. It is a plus only, my dear students. Pi of k is equal to pi of n minus tan inverse b suffix k. What is a b suffix k here? 6.32 pi k whole square. Denominator is the same. And here also 1.576 denominator is the same. So tan inverse of 6.32 pi k whole divided by 1.576. Okay, my dear students, this is a b of k only. I am not taking the square here. What is a b of k? 6.32 pi k. This is a numerator. And a of k is a 1.576. Denominator is the same. So both the denominators will get cancelled and take the 1.576. So 1.576 is get cancelled with the 4 times to get the 6.32. So tan inverse minus tan inverse 4 pi k. Substitute this 4 pi of k in this equation. So cos k omega naught t and the minus tan inverse 4 pi k value is a pi of k. Now it converts trigonometric Fourier series. What we find there, a of 0, a of k and the b of k. Using these equations, a of 0, a of k, b of k, can find out the d of 0 as similar of a of 0 here. You can find the d of k, nothing but it is a magnitude. This is a magnitude, my dear students. Square root of a square and the b square. This is a simplification factor, and there is a small mistakes is there, my dear students, here. Right. Please note that one. And pi of k is equal to minus tan inverse b suffix k and a of k. And final answer is this one. X of t is equal to 0.7869 plus sum of k equal to 1 to infinite 1.576 under root of 1 plus 4 pi k whole square cos k omega naught t minus tan inverse 4 pi k. This is the actual polar form of the Fourier series. Understood? For the given exponential signal or the periodic exponential signal with a time period of 0 to 0.5, we find the trigonometric Fourier series, and also we find the compact trigonometric Fourier series. Now, you can go to find the exponential Fourier series also. Exponential Fourier series. And plot the magnitude and the phase spectrum. It is a very, very important, my dear students. For the given periodic signal with a period of 0 to 0.5, it is an exponentially decaying function, e power minus t. Find the trigonometric Fourier series, we already did. Find the compact trigonometric Fourier series, that is also we did now itself. Now we go for to find exponential Fourier series. The third one, the classification, there is a third one, exponential Fourier series. What is the formula for the exponential Fourier series? According to the analysis equation, x of k is equal to 1 by t, the integral 0 to t, 1 by t, the integral 0 to t, x of t, e power minus j k omega naught t dt, my dear students. Okay, this is an analysis equation. In the exponential Fourier series, there is two equations out there. One is analysis equation, another one is a synthesis equation. Analysis equation, nothing but the coefficient x of k. In that, what is the x of t is given? Nothing but exponentially decaying function, e power minus t. And what is the period here? 0 to 0.5. What is the angular frequency? 2 pi by t, nothing but 4 pi. After substituting the 0.5 here in denominator, get in the numerator, this is a 4 pi. These are the given. So substitute in the analysis equation, x of k is equal to 1 by 0.5, the integral 0 to 0.5, e power minus t, e power minus j k omega naught is a 4 pi, into t is there, my dear student. Actually, there is some mistake here, into t dt. So in this integral, both are exponential signals only. So bases are same. Now you can add the power. So both are negative exponentials only, minus, the first one is a 1, plus jk 4 pi, and this t is a common term, into dt. Now what is the integral of e power minus jx or j into t dt? You get the coefficient is in the denominator is 1 by minus 1 plus j 4 pi k, and e power minus 1 plus j 4 pi k into t, with upper limit is a 0.5 and lower limit is a 0. Okay, my dear students. In the integral, whatever the coefficient is there with respect to your applying, you'll get in the denominator. Now, if suppose you can apply the derivative, whatever the coefficient there with respect to that value, you'll get in the multiplication. Understood? So 2 is here, 1 by 0.5 is nothing but the 2, e power minus 1 plus j k 4 pi into t, and denominator is a minus 1 plus j 4 pi k, with upper limit is a 0.5 and lower limit is a 0. Now substitute upper limit and the lower limit in this exponential. See, then you'll get minus 2 by 1 plus j 4 pi k. So first of all, you can apply e power minus 1 plus j 4 pi k into t is 0.5, minus e power 1 plus j 4 pi k into t is 0 there. Nothing but e power 0. E power 0. The second term becomes 1. And in the first term, e power, you can separate these two factors, e power minus 0.5. And because the 0.5 into 1, 0.5 into 1 here. And e power minus 0.5 into 4 pi k is nothing but the 2 pi k. I already told in the previous classes, e power 2 pi is there. Either it is a positive or negative, whatever it is there. Exponentially, the negative or is a positive with having 2 pi is there. See here, e power minus j 2 pi k or e power plus j 2 pi k also. Whatever the value is there, that is always a 1. Because e power jx is a cos x minus j sin x, e power plus means cos x plus j sin x. Sin value, the 2 pi is always a 0 and cos 2 pi is always a 1. 1 minus 0 or 1 plus 0 becomes of 1 always. Always remember this one. E power 0. So e power minus j 2 pi k value is a 1. So if x of k is equal to minus 2, 1 plus j 4 pi k, I told you the e power minus 0.5. Using the calculator, you can find out, my dear students. Once again, I am saying e power minus 0.5 is equal to 0.606 only, you get, my dear students. So 0.606 and this value is a 1 minus 1. So 1 minus 0.606 is a 1.57. Multiply with the 2, we'll get the 0.7869. 7869. So actually here it is a minus value you have to get 1.5 something, and minus into minus is it becomes of the plus. X of k we got. Understood, my dear students? And in the same exponential Fourier series, we have synthesis equation is also there. What is the synthesis equation? X of t is equal to sum of k equal to minus infinite to infinite. Here the x of k into positive exponential. E power plus jk omega naught t. What is the x of k? We got 0.7869 whole divided by 1 plus j 4 pi k. This is synthesis equation. Synthesis equation in exponential Fourier series, and this equation is analysis equation. Analysis equation. Nothing but the coefficient. Fourier series coefficient we can call it as. So we got x of k and the x of t. But they are asking that plot the, see here, obtain the exponential Fourier series and also plot the magnitude and the phase spectrum of this periodic signal with the period of 0.25 exponentially decaying function. We got the analysis equation, the coefficient x of k, and the synthesis equation x of t in terms of x of k, my dear students. Synthesis equation x of t in terms of x of k. Now to obtain the magnitude and the phase spectrum of x of k, this is the equation. To obtain the magnitude and the phase spectrum of x of k, what is the x of k? 0.7869 whole divided by 1 plus j 4 pi k. 1 plus j 4 pi k, my dear students. So rationalize with the denominator. If you have the plus is there, you can take the minus conjugate function and multiply and divide. The rationalization we can call it as 0.7869 1 plus j 4 pi k into 1 minus 4 pi j 4 pi k by 1 minus j 4 pi k. Multiply the numerator 0.7869 into 1 minus 4 pi k, and the denominator we can see here a plus b into a minus b. A plus b into a minus b. What is the formula? The a plus b into a minus b, a square minus b square. What is the a here? 1 whole square. What is the b here? J 4 pi k. J 4 pi k. A plus b into a minus b is a square minus b square. Here the square term of the j is also there. What is the j square is equal to? J square is equal to minus 1, my dear students. J square is equal to minus 1. So a square minus b square. In this minus and minus it becomes of the plus, and 4 pi k whole square. 4 pi k whole square. Now I can rewrite this expression as real term and the imaginary term. What is the real term? 0.7869 whole divided by 1 plus 4 pi k whole square as a real term here. And imaginary coefficient here, 0.7869 into 4. 0.7869 into 4 pi k whole divided by 4 pi k whole square. Now I can find out the magnitude. Magnitude, if suppose you can assume this x minus iy, what is the magnitude? Under root of x square plus y square. What is the x here? 0.7869 whole divided by this function. And similarly the b square, not the b square, y square. What is the y here? 0.7869 into 4 pi k whole square whole divided by this one. Both the denominator is the same, take that to common. 0.7869 whole square, and here also 0.7869 whole square into 4 pi k whole square. Take the common of 0.7869 whole square, you get the 1 plus 4 pi k whole square. So see here, 1 plus 4 pi k whole square, and the denominator is a square term is there. Get cancelled, and here the square and the square root to get cancelled. So numerator becomes of 0.7869 and denominator becomes of under root of 1 plus 4 pi k whole square. This is a magnitude, my dear students. Magnitude of x of k we got 0.7869 under root of 1 plus 4 pi k whole square. Alright. So you have to find out also the magnitude and the phase also. We got the magnitude. I can find out the phase. Phase is angle with x of k is tan inverse imaginary coefficient by the real coefficient. What is the imaginary here? 0.7869 into 4 pi k. Denominator is the same for the both, and the real term is 0.768. So 0.678 and 0.678, 0.7869 and 0.7869 get cancelled, and 4 pi k minus tan inverse 4 pi k only. Follow my dear students. Now use this magnitude of x of k we got as 0.7869 whole divided by 1 plus 4 pi k whole square. And this is a phase angle, angle x of k. The magnitude, and this one is a phase. And in this example, they're asking that find out the exponential Fourier series and also the plot, magnitude, and the phase vector. What is the magnitude? We got 0.7869 whole divided by 1 plus 4 pi k whole square, and the phase is minus tan inverse 4 pi k. Take the values of k from 0, minus 1, minus 2, minus 3, 1, 2, and 3. Substitute here, and k is equal to minus 3. K equal to minus 3. First of all, if I am finding out the 0, k is equal to 0. What is the value? 0.7869 whole divided by 1 plus 4 pi k. K is a 0 now. 0 whole square. Nothing but this value is a 0. 0.7869 only. See here, 0.7869. At the same time, what is the k value here? The k is equal to 0. I am taking with an angle. 4 pi k, 40 means tan inverse 0 value. What is a tan inverse 0? Sin inverse by cos inverse. Sin 0 is a 0. So the value is a 0. The same way, using the calculator, my dear students, you find out these values by substituting the minus 1, k as, and substitute the minus 2 with the k, and minus 3, find out the magnitude and the phase. So you'll get these values. Don't skip these, my dear students. Use the calculators and find out the values. Whatever I wrote here, it is the same or not. Sometimes I will also the mistake did. So you can find out these values and plot the graph. Fine. So 0.028, see for the -3, because it is a periodic signal, for the -3 here, 0.028 and the 0.028 for the both the positive and the negative values. Observe here. For -0.2 and the +2 also, the same value you got 0.3, 0.0312, 0.0312. And -1 and the +1 also, 0.06464 and 0.6024. Angle is also same with plus and minus. Here also the value is the same with the negative and positive, and here also the negative and positive values. Using these values, you plot a graph, my dear students. At zero, what is the value of at 0.786? Let us, this is a 0.7869. Okay, my dear students. Means it is a gradually decreases when 1.06. So definitely this value is a 0.0624. And still it is a decreases, my dear students. It decreases the value 0.0312. And 3, still it is a decreases 0.0208. As for this, my negative values also the same thing. These two are equal, and these two are equal, and these two are equal. This is a magnitude plot. Magnitude plot and phase plot. See at k is equal to 0. What is a k here? The k variable, and this is also k variable. At k is equal to 0, angle is a 0. And k is equal to 1. What is an angle here? Minus 1.49. Means, my dear students, this is a in the radians. You can keep this as a angle also in the degrees. Either you can take any one. This is a value of radians, my dear students. You can find out the value of the degrees in terms of the degrees also. Okay. Convert the degrees into the radians or the radians into the degrees. What I show here, these values is radians values, not the degree values, my dear students. So the 1, what is the value of 1? It is a minus. For positive values, there is a negative angle, minus 1.4 and minus 1.53. Still it is decreases. Minus 1.54. Still it is goes in the downward direction. And now it is the same positive value also. Minus 1 is a 1.4. Is a 1.4, my dear students. And it is a increases 1.53. Still it goes on increases 1.544. Okay. Understood, my dear students? Like that, you can plot the magnitude plot and the phase plot by finding out exponential Fourier series x of k, the coefficient, and the angle minus tan inverse 4 pi k, and the magnitude x of k. By substituting of, take this some values on. Otherwise, you can take the 0, 1, 2, minus 1 and minus 2. Don't find the minus 3 and plus 3 also. Got it? Okay. With the same example, the given periodic signal exponentially decaying with 0 to 0.5, we find first one is trigonometric Fourier series. In that a0, a suffix k and b suffix k find, and you can substitute in the x of t equation. And also we can find with the same example compact trigonometric Fourier series by using the same a0, a suffix k and b suffix k. We find the d0, d of k and pi of k, and d0, d of k and pi of k can substitute in the x of t equation to get the compact trigonometric Fourier series. And finally, the third one, exponential Fourier series. Exponential Fourier series by using the analysis equation, we find the x of k, and synthesis equation in terms of x of k, x of t is equal to, using this x of k, we can plot the magnitude and the phase spectrum. Magnitude and phase spectrum. So like that, we can find out all the trigonometric, all the Fourier series, classification of Fourier series, exponential, compact, and the trigonometric Fourier series. Any of the example. Okay, you see here, find the exponential Fourier series and plot the magnitude and phase spectrum of half wave rectified sine wave. See, the positive half only is shown here, and there is no any negative half on the sine wave. Half wave rectifier. You see that for half wave rectifier only you will get the positive cycle only. There is no any negative cycle. Understood, my dear students? So half wave rectifier sine wave. So the given the x of t is equal to this x of t with the duration of 0 to t0 by 2. 0 to t0 by 2 is a magnitude. Why I wrote it is a there. See, this is a is a magnitude, my dear students. A into is a sine function, sine omega naught t, in the duration of 0 to t0 by 2. And from t0 by 2 to the t0 is a 0, because it is a half wave rectifier. And again, it is repeated the same. Positive cycle, and there is no any negative cycle, it is a 0. And positive cycle, there is no any negative cycle, 0. So full cycle is 0 to 2 pi. Following, my dear students, 0 to t0. What is the t0 here? The 2 pi of. From t0 to t0 by 2 less than or equal to t, less than the t value, less than the t, not the equal, less than the t, the value is a 0. From 0 to t0 by 2 is a into sine omega naught t. So this is a given equation. You can find out trigonometric Fourier, not the trigonometric Fourier, is exponential Fourier series. What is the exponential Fourier series? X of k is equal to 1 by t, integral 0 to t, x of t e power minus jk omega naught t dt. Please listen carefully, my dear students, otherwise it is somewhat difficult to understand. So what is a t here? Up to the value of 2 pi, my dear students. Up to the value of 2 pi. 1 by 2 pi integral 0 to t x of t e power minus jk omega naught t dt. So t naught is equal to 2 pi, or it's a t, 0 to t. A into sine omega naught t, and exponential value here, e power minus j omega naught t, omega naught t dt. Jk omega naught t dt. This is a t, my dear students, and this is a k function. And a by the 2 pi, the integral 0 to 2 pi sine t e power minus j k into t. You know, this is the equation for the e power ax by e power ax sine bx plus c. Okay, e power ax sine bx, actually the c is a 0 there. So what is the formula for e power ax sine bx into dx? E power ax by a square plus b square, a square plus b square, a into sine bx minus b into sine b into cos bx. It is the plus for e power ax cos bx, my dear students. See, what is the a here? Is you observe e power ax. Here the t, and here it is a x. A is a minus jk. A is minus jk. And what is a b? X is there, then b value is a 1. So instead of x here, the t is there and 1, b is equal to 1. And there is no any c. C is 0. C is 0. Instead of x here, we are taking the t. See, x is equal to t. So a by the 2 pi e power, a value. A value is e power, a is minus jk into t whole divided by a square minus jk whole square plus 1 and whole multiplied with a as minus jk sine t minus b value is a 1, 1 into cos bx, b value is a 1 and the t, 0 to pi. 0 to pi value. Okay. And substitute the pi value, substitute the pi as upper limit. A by 2 pi is already the multiplication factor, e power minus jk, the t is pi, whole divided by the same thing denominator, minus jk sine t is a pi, minus cos pi. These are the two terms for substituting of upper limit. And the lower limit, these two terms, e power 0, the denominator is the same, 1 plus minus jk whole square and minus jk sine 0 and cos 0. What is a sine 0 is the 0, cos 0 is the 1, cos pi is a minus 1 and sine pi is a 1. Now see the simplification factor. A by 2 pi e power minus jk whole divided by this one and 1 by the function. The first term will get as, because of cos pi is a 1, cos pi is a 1, and next the second term, the fourth term is a 0 and 1 by minus jk whole square plus 1. Simplify this, a by 2 pi and take the common of minus jk whole square plus 1, and here the numerator is e power minus j pi k plus 1. Okay, what is a j square? J square is nothing but minus 1 minus 2. J square is a minus 1. So inside there is a minus a whole square, means is a plus only, and becomes of j square k square. What is a j square? Minus 1. J square is a minus 1 and k square. So it is a k square value. Its total function is becomes of minus k square. Its total function is a minus k square. And e power j pi k. E power j pi k means e power jx is cos x plus, or the plus minus cos x minus j sin x. Okay, let's see it again. What is the e power minus jx is equal to? Jx is equal to cos x minus j sin x is equal to, what is the value of x here? Cos pi k minus j sin pi k. Okay, simplify this function, or otherwise can take only this function as is a minus 1. Okay, cos pi is a minus 1. So minus 1 whole power k. Minus 1 whole power k value, the cos pi. So substituting this equation here, the a by 2 pi k, a by 2 pi, a by 2 pi, and the denominator becomes of, what is the denominator? 1 minus k square, because this value is a minus k square. 1 minus k square and whole multiplied e power minus j pi k is becomes of minus 1 whole power k plus 1. Minus 1 whole power k plus 1. For k is equal to 0 plus or 2, 4 and 6 values is a 0 value, because it is a 1 minus 1 minus 1. Otherwise, a by 2 pi k 1 minus k square is the values of k, and if it is a 0, 0 for the values of plus or minus 1, plus or minus 3, nothing but it is odd functions. Odd functions. Following. You got the x of k here. So to plot the magnitude and the phase, take the k is equal to 1, find out the value of x of k. Similarly, k is equal to minus 1, we got the a by 4j and minus a by 4j. And next, you see here, for the values of 0, plus or 2, plus or 4, these are value. And k is equal to plus or 1, plus or minus 1, plus or minus 3, and plus or minus 5, the value is 0. And the remaining, the k is equal to 1 and the k is equal to minus 1 is a positive value and the negative values. So using this, you can plot the graph. What is a 0? 0 is equal to a by pi. This is a value of a by pi. Understood, my students? And what is the value of 1? At k is equal to 1, it is also a by 4. And the k is equal to minus 1 is also the a by 4. And the two values a by 3 at k is equal to 2. See here the 2, nothing but the 2 square is a 4. 1 minus 4 is a 3. So a by 3 pi as a positive values. And for the negative values, a by minus 3 pi. Okay, the same thing, a by 3 pi. Whatever it is a minus or the plus is a square is there, my students. A square is there. So actually this is not the a by the 3 pi, my dear students. See what they are saying here, a by 1 minus k square. A by 1 minus k square means it is in the negative. A minus a by 3 pi, and it is also in the negative only. Minus a by 3 pi. Understood? And this value is a negative value and this value is a positive value. One time it is a positive and one time it is a negative. Similarly, you can find out the phase angle also. Similarly, you can also find out the phase angle. What is the phase angle? Saying that tan inverse imaginary coefficient by the real coefficient. What is the real here? There is no any real term because it is a 0 plus j into a by 4. 0 into a by 4. Okay. Anything by 0 is nothing but infinite. Tan inverse infinite is a pi by 2. So for positive values is a negative minus pi by 2. And for the negative values plus pi by 2. For positive values is a minus pi by 2 and negative values is a minus pi by 2. Understood, my students? It's because of tan is nothing but a sine by cos. Sine of minus theta, nothing but it is a odd function, minus sine theta by cos theta. Again, the minus value only you will get. Okay, tan of minus function is always minus the value. Understood? For positive value, here the k is equal to minus pi by 2. So I represented in the downward. And for k is equal to minus 1, the angle is a pi by 2. Or you can find out it is a the radians also. Whatever we did in the previous example. Understood, my student? So like that, we can find out all the terms, whatever they given, to plot magnitude and the phase spectrum. Magnitude and phase spectrum. This x of k is equal to 1. Why I separately find out that k is equal to 1 means k is equal to 1. Even if they are saying that this is 0, it is not the 0 at k is equal to 1 and the minus 1. So when k is equal to 1, it is separately you will get this expression. To simplify that one, you will get a by 4j. And k is equal to minus 1 minus a by 4j. Following, my students. So take these two as screenshots and simplify. The given example, find exponential Fourier series and plot the magnitude and the phase spectrum. By using this plot, not the plot, it is a given spectrum as a half wave rectifier sine wave, as x of t is in between of these two factors and 0 in between of the t naught by to the t naught. So take it as 0 to pi, the total function only. Actually, it is a 0 that second term. So 0 to t naught by 2. 0 to t naught by 2. What is a t naught by 2? Is a pi only, my dear students. The remaining term is a 0. The remaining term is a 0. So take it as a 0 to pi. 0 to pi here. Understood? 0 to pi. So a sine omega naught t and e power minus jx, not the jx, j omega naught k into t dt. Using this trigonometric expression, substitute the values and simplify. Simplify. After that, you'll get the x of k is equal to, for positive even numbers and odd numbers. Or otherwise, you can find out the k is equal to 1 and the k is equal to minus 1. Finally, the x of k is equal to 0 plus r minus 2 plus r minus 4. It is not there, my dear students, actually. So don't take this as plus r minus 1. It's not the 0 here. It's only for 0 plus r minus 2 plus r minus 4 plus r minus 6. And this value is a 0 for plus r minus 3 plus r minus 5 plus r minus 7 and so on. But k is equal to 1 and the k is equal to minus